crystal diode is a single PN junction. E-type material, N-type material. So only one junction is there. So it's having a single PN junction. The answer is one PN junction. Second one, a crystal diode has forward resistance of the order of, already I have told, it is of the order of ohm. Reverse resistance is the order of kilo ohm. Forward resistance is of the order of ohm. The arrow of the crystal diode symbol is positive with respect to bar. So arrow is positive with respect to bar. This side positive, this side negative. So you know this is forward bias. So diode will be dash biased, means the answer should be forward bias. Arrow is positive with respect to bar. Bar is this big line is called bar. So arrow is positive with respect to bar, means forward bias. The reverse current in a diode is of the order of, reverse current is of the order of microampere. We have done in previous chapter also. So it will be in microamps. The forward voltage drop across a silicon diode is, now the question is silicon diode. So the answer is 0.7.
0.7.
Yeah, previously your germanium, so 0.3 you have written. Here it will be 0.7. A crystal diode is used as rectifier. We know that crystal diode application is rectifier. Zener diode application is voltage regulator. Amplifier is different thing, that is BJT and FET you use. Oscillator you use crystals. So crystal diodes, normal PN junction diode, we generally use for rectifiers. There are three rectifiers: half wave rectifier, full wave bridge, and full wave center tap. We will teach in next classes. But rectifier is a circuit which converts from AC to DC. Already we told. So all the crystal diodes we use to design rectifiers. The DC resistance of a crystal diode is dash of its AC resistance. Obviously DC will be more. Why DC will be more? If you have remembered the VDID, as we told, VDID of lamp, what we have done, we got that at 0.4 volt or something, current flow starts 0.1 milliamps or something. Then the VD ends at 0.67 or 0.7. Current we got at here 19.3 or 19.7, something we have got. So minimum voltage is 0.4 volt. So DC resistance capital RD, minimum DC resistance is 0.4 volt by ID is 0.1 milliampere. So you can see 0.4 volt by 0.1 milliampere. So it's around 4 kilo ohm. Volt by milli equals to kilo. 1 by milli equals to kilo. Point cancel. So it is around 4 kilo. So the minimum resistance or something it will get in kilo ohm, DC resistance. But AC resistance will get in ohm. So obviously DC resistance always will be more. DC resistance of a crystal diode, always we found, those who have done the lab, those who have calculated the resistances, they know these things. DC resistance always it's more than AC resistance. So it's more. An ideal crystal diode is one which behaves like a perfect conductor. We know in forward bias, diode should behave like a conductor. In reverse bias, diode should behave like a insulator. Forward में जाने देगा, reverse में रोक देगा. So this should be the behavior of an ideal diode. Practically, there should be resistances, but ideally we will not understand any resistance. We will not assume any resistance. So in ideal case, in forward bias, diode should behave like a conductor. So it should behave like a conductor. The ratio of reverse resistance and forward resistance of a germanium crystal, it is also a wrong question. You cannot answer because it depends on doping. If doping changes, resistance changes. The leakage currents in a crystal diode is due to
minority carriers.
Minority carriers. If the temperature of a crystal diode increases, then leakage current, any current increases, any temperature increases, current also increases. Resistance decreases, current increases, because temperature in semiconductor it will increase the number of carriers. So ultimately, if the number of carriers will increase, current will increase, resistance will decrease. The PIV rating of a crystal diode is that of equivalent vacuum diode. That is also cannot be told because it depends on doping. So question number 12 is also wrong question. If the doping level of a crystal, yeah,
PIV.
PIV peak inverse voltage. We have told PIV is peak inverse voltage.
Peak inverse voltage.
Characteristic in the reverse characteristic, this is called breakdown. मतलब यहाँ पे डायोड खराब हो जाता है, तो खराब होने का दिस इज कॉल्ड ब्रेकडाउन वोल्टेज VB. खराब होने का जस्ट पहले दिस वोल्टेज को बोलते हैं PIV. PIV means peak inverse voltage at reverse bias. How much voltage a diode can tolerate? कितना ये सह सकता है, उसके बाद ही खराब हो जाएगा. So it depends on doping. If you dope more, this breakdown will go closer. So अभी PIV यहाँ पे है, ज्यादा डोप कर दोगे यहाँ आ जाएगा, और डोप करोगे यहाँ आ जाएगा. So if you increase doping, PIV will go closer to the origin. So that's why question number 12 is wrong. If the doping level of a crystal diode is increased, the breakdown voltage, just now you have told breakdown voltage will go closer to origin. So magnitude of breakdown voltage will decrease. So if the doping level is increased, the breakdown voltage will decrease. The knee voltage of a crystal diode is approximately equals to threshold voltage. Here answer is given: applied voltage, breakdown voltage, forward voltage. So it is barrier potential. Barrier potential and threshold voltage meaning same, and knee voltage all are meaning same. Knee voltage, barrier potential, threshold voltage all are same. 15. When the graph between current through and voltage across a device is straight line, any straight line graph is called linear graph. So question number 15 answer will be linear graph. Any straight line graph, y equals to mx or y equals to mx plus c. This is y equals to mx plus c. This is y equals to mx. This is y equals to minus mx. This is y equals to mx minus c. So all these graphs you know. Any straight line graph is called linear graph. When the crystal diode current is large, the bias is, we know current will be large in forward bias only. So when the diode current is large, the bias is forward bias. In reverse bias, current is very less. A crystal diode is a non-linear device. We know the response is not straight line. The response is like this. It's not a straight line. So crystal diode is a non-linear device. It's not a linear device. A crystal diode utilizes which characteristic for rectification? We haven't started rectifier yet. From next class we'll start. Both the characteristic we use, reverse and forward. Because for rectification, we need to pass the voltage in one direction and stop the voltage or signal at other direction. So both the characteristics we will use here. So for rectification, we will use both the characteristics, forward and reverse. When the crystal diode is used as a rectifier, the most important consideration is PIV. As just now I have told, PIV is peak inverse voltage. It's both important because if you use it at more voltage compared to PIV, it will be spoiled. खराब हो जाएगा. So knowing PIV is very much important. So this is the most important consideration in case of rectifier. If the doping level of a crystal diode is increased, the width of depletion region, so doping level बढ़ने से width भी बढ़ेगा. As we told, if we increase the doping level, its depletion layer is also increased. So it will increase. A Zener diode, so all the diodes I told, if it is diode, it's having one PN junction. Any diode, that may be Zener, that may be crystal, it's having a single PN junction. If the doping concentration is more, it will become Zener diode, but all diodes are having a single PN junction. So a Zener diode has a single PN junction, one PN junction. A Zener diode is used as
voltage regulator.
Application we have told Zener diode is used as a voltage regulator. The doping level in a Zener diode is that of crystal diode, obviously more. We increase the doping level in Zener diode. So compared to crystal diode, it is more. The answer will be more than. The Zener diode is always reverse connected, that way forward connected, but if you want to get the Zener property, we need to connect it in
Reverse
reverse.
forward.
Yeah. If we need to use its Zener property, we need to connect it in reverse. In forward bias, it's same like crystal diode. So a Zener diode utilizes dash characteristic for its operation, obviously reverse. Because its operation mainly is voltage regulator, and for regulation, it uses its reverse characteristics, which is the breakdown characteristics. In the breakdown region, a Zener diode behaves like a constant voltage source. We haven't taught it yet. We will teach you. The Zener diode will behave like a constant voltage source because across Zener voltage will be fixed. It is VZ. If it is 5.2 Zener, 5.2. If it is 9.2 Zener, 9.2. Depending on its Zener voltage or breakdown voltage, a constant voltage you get. So it can be used as a constant voltage source. If Zener diode is destroyed, obviously, ज़्यादा current दोगे तो destroy हो जाएगा.
Than rated current.
Yeah. So a Zener diode is destroyed if it carries more than rated current. Series resistance connections we haven't taught yet, so these questions we will discuss after finishing that thing. A Zener diode is all diodes are non-linear device. Diode is not a linear device. The characteristic is not a straight line. So it may be a Zener, may be a crystal. It's a non-linear device. A Zener diode has
breakdown.
SAR. Yeah, SAR. It's SAR because it's not undefined. It's defined by the manufacturer. It will be written. It is how much breakdown voltage. It is not obviously zero. There will be some breakdown voltage, 5.2 or 9.2, whatever may be the Zener voltage. That much drop will get. So SAR will be the answer here. Dash rectifier. So rectifier we haven't started yet. We will not tell about this question. Means AC power is converted into DC power for हमको चलाना है सब electronics applications. That's why we convert from AC to DC. Means AC power is converted into DC power, or it's not lighting purpose. Lighting is a different thing. It's for not heaters. It's for using in electronic components. So C will be the answer. The disadvantage of half-wave rectifier is components are expensive. Diodes must have a higher power rating. Output is difficult to filter. No, not a single answer is correct here. The main disadvantage of half-wave rectifier is efficiency is less. As half of the AC is becoming DC, its efficiency is around 40.6%. Whereas efficiency of full-wave rectifier is 81%. So that's why that is the main disadvantage. So here we will write that none of the above is the answer. Half-wave rectifier we haven't taught you yet, so this we will discuss after the class. Ripple factor after the class. Transformer need after the class. This is also after the class. This is also rectifier after the class. 39. If the PIV rating of a diode is exceeded, obviously the diode will be destroyed. Is exceeded मतलब तुम बढ़ाए हो. अगर तुम उसका करंट बढ़ा दिए, if you increase the current, if it is exceeded, then obviously diode will be destroyed. Filter capacitor also is not taught yet. Maximum efficiency of half-wave rectifier will teach, but you remember just now I have told that maximum efficiency of half-wave rectifier is 40.6%. For full-wave rectifier it is 81.2%. The most widely used rectifier is bridge full wave rectifier. In maximum cases, you will find this bridge full wave rectifier because there are lots of reasons. Center type transformer rectifier also you can use, but the PIV rating of diode should be much higher compared to bridge rectifier. In bridge rectifier, the PIV rating requirement is less. So we will teach you bridge rectifier or rectifiers. But just now you remember that maximum applications of rectifier is bridge full rectifier. In most cases, in most rectifier design, this rectifier you can find. So we have discussed almost all questions except some questions which we are not covered yet for the internal exams. These questions are enough if you can answer. Anybody is having any doubts, they can ask.
धन्यवाद सर. बोले इसी में
Any questions, any doubts?
ये क्या रिकॉर्ड कर रहे हैं?
In each chapter, if you go